Hey everyone, welcome to the next episode of the Physics Podcast. Me, Superstar, Mr. Deal. This episode we're going to look at Newton's laws. Newton's got 3 laws. The first law says an object at rest tends to stay at rest, while an object in motion tends to stay in motion unless acted on by an external unbalanced force. Sometimes this law is known as the law of inertia. Inertia is just a science word for saying objects tend to keep doing what they're already doing. In the first experiment here, we've got Rainbow Dash and her best friend sitting precariously over a large vat of acid. I'm going to grab the piece of paper right out from under this large vat of acid. I hope they don't fall in. Amazing, it worked. What we see here is we had an object at rest. Its natural tendency was to stay at rest. The force I applied was on the piece of paper, and there wasn't enough force to disrupt this. In our next experiment, we've got some cars. Yo dog, I heard you like some cars. So I put a car on the car. Now if I set this object in motion, we're going to see that this object's going to stay in motion even after the collision. If this had been a person and this had been a windshield, you might understand a little bit better why we say always wear your seatbelts, kids. In the third experiment, we want to look at the relationship between mass and inertia. It turns out that the greater the mass, the greater inertia an object has, the greater the tendency to keep going or the greater tendency to remain at rest. If we give each of these masses a whack with a ruler, we can see the difference. Well, clearly we can see that the greater mass had a greater tendency to stay at rest. We can also use this to show Newton's second law, force equals mass times acceleration. It's a mathematical way to show the relationship between the 3 variables of force, mass, and acceleration. What we see is that with a greater mass, there'll be a smaller acceleration. With a smaller mass, there's a greater acceleration. So mass and acceleration are inversely proportional to each other. However, if you look at the difference between a small force and a large force, obviously acceleration is directly proportional to force. Newton's third law says that for every action, there's an equal and opposite reaction. What that means is when a force is applied to an object, that object will apply an equal and opposite force on wherever that first force came from. So forces naturally occur in pairs. Now, if I put my feet up on this desk and push off with my chair, you can see evidence of a force being applied to me and to the desk. Now, what we saw was that a force was applied to me because I took off towards the camera. You might have seen the desk vibrate a little bit. That's evidence of me applying a force to the desk. The desk moved because of my force on it. I moved because of the desk's force on me. Anytime there's a force, there's also a reaction force. We know that gravity is going to attract this tennis ball towards the ground. That's a force. But if we're going to say that for every action there's an equal and opposite reaction, we can also say that the ball is going to attract the earth upwards towards it. Now, we didn't have any earthquakes happen just then. We've got to keep in mind about Newton's second law as well. Even though there's an equal force of attraction between the ball attracting the earth and the earth attracting the ball, keep in mind about the difference in size. Because of the Earth's large mass, it's not going to go anywhere. We also saw that with the greater mass of this desk, it didn't move as much when I pushed off.